Hi everyone, I'm Aman Chokshi, a PhD student at the University of Melbourne. In this lightning talk, I'm going to briefly tell you how we measured MWA beam shapes using satellites. Our experiment measured the beam shapes of 14 MWA tiles at both polarizations and at multiple pointings using communication satellites in the 137 MHz band. Our concurrent observations didn't disrupt the MWA observation schedule and used only affordable equipment such as RF Explorer spectrum analyzers and Raspberry Pis. RF data was projected along satellite trajectories to gradually build up all-sky beam maps. We observed multiple environmental effects which perturbed the beam shapes from the cutting-edge FEE simulations. We attribute distortions in the side lobes to local foliage and soil obscuring the ground screen. Gradients in the soil below the ground screen also led to pointing errors of up to 1.5 degrees. You also see rotations in the antenna which distort the beam shapes. In the bottom panel of this figure, you see a gradient at the edge of the primary beam, which is the result of pointing errors at the edges of the null. Here I'm flicking through multiple MWA tiles and we see the beam shapes differ significantly from each other. This could be a serious effect that needs to be pursued further. In future studies, I hope to use such beam shapes and measurements to improve EOR limits and reduce polarization leakage for RM measurements. There's an open source software package called Embers, which can enable you to do the same for your telescopes. Look forward to talking to you all on Slack further.